All right, y'all. We are on our final set of notes for this unit, so let's go ahead and get started. We're going to jump into thermal energy. All right, so thermal energy is the sum of kinetic and potential energy of the particles in an object. So thermal energy will increase as your mass increases, and your thermal energy will increase as temperature increases. Temperature, however, is a measure of the average kinetic energy of particles in an object. This means that the higher the temperature, the faster the particles are moving. So thermal energy is different from temperature, so make sure you know the distinction. So how do you know if someone has been sitting in your chair? Thermal energy always flows from higher temperature objects to lower temperature objects. So we measure this by heat. That's a capital letter Q. That's the transfer of energy from one object to another. It's measured in joules. Let's go ahead and continue to talk about transfer of thermal energy. So there's no such thing as cold, quote unquote. It's because when you feel cold, you are simply feeling the absence of heat. So for example, what would happen when you hold a cold drink and your hand starts to feel cold? Well, sometimes when the heat flows into an object, the change of heat is a positive change, so it becomes warmer. When the heat flows out of an object, the change in heat is negative, which means it gets colder. So the reason why things start to feel cold in your hand is because the energy transfer is going from your hand, which is warmer, to the cold water bottle. So you start to feel that absence of heat. So there are three ways that this can be transferred. We've got conduction, which is a transfer of energy through matter by direct contact of particles. So solids are best conductors of heat, and particles are already so close together that contact is pretty easy. Next is convection. This is a transfer of energy by the movement of heated particles. This only occurs in liquids and gases. This is when currents move heat from warmer parts to cooler parts of a substance. Rooms do this. When you're boiling water, it does this. That's the easiest way to remember it. Next and last, we have radiation. Radiation is the transfer of energy through electromagnetic waves. It occurs fastest in gases, and it can be absorbed or reflected. This means that it can travel through space and between molecules. This is pretty unique and pretty awesome. All right, so some materials that can help transfer heat well or not transfer heat well. We call conductors the ones that allow heat to flow easily because they're a material that allows that to happen. And then some examples are like metals and skin. So your skin allows for the heat flow pretty easily. That helps with your body temperature regulation. And pots and pans obviously have to be able to do this so you can cook. Now, insulators, on the other hand, are materials that do not allow heat to flow easily. So things like air, wood, styrofoam, plastic, fiberglass, your guys' like cups that are insulated. That's why they're called insulated cups, because they've got some kind of insulation to keep things cold and hot things hot. So then we have to talk about specific heat. So specific heat is the amount of heat needed to raise the temperature of 1 kilogram of a material by 1 degree Celsius or Kelvin. This is specific to different types of materials, and it's measured by a calorimeter. The equation to find our heat is mc delta T. Q is the change in thermal energy or heat. We've talked about this. It's measured in joules. M is our mass. It's measured in kilograms. And C is specific heat. This is a constant depending on the material. This is measured in joules per kilogram degree Celsius. And then we have delta T, which is a change in temperature, which is TF minus TI. TF is your final temperature and TI is your initial temperature. Those are measured in degrees Celsius. So for example, a wooden block has a mass of 20 kilograms and a specific heat of 1700 joules per kilogram degrees Celsius. So we're going to find the change in thermal energy of the block as it warms from 15 degrees Celsius to 25 degrees Celsius. So first, we know our mass is 20 kilograms. Our C is 1700 joules per kilogram degrees Celsius. It gives us that. Our initial temperature is 15 degrees Celsius, and our final temperature is 25 degrees Celsius. And we're looking for Q. So we're going to use our normal equation, and we're going to set it up just like this. So we're going to do 20 times 1700 times 25 minus 15. Let's go ahead and do the subtraction first, the far right. So 25 minus 15 is 10. Now you can go ahead and multiply across the board, and our answer is 340,000 joules. That would be correct because we're looking for heat. Now let's go ahead and practice. So I'm going to give you guys a couple minutes. Go ahead and work these things out, and then I'm going to put up the answers. All right, number 1, this should be your answer. And number 2, this should be your answer. Now we're going to go ahead and do some practice tomorrow. And hopefully we can get to understanding this. All right.